Hi everyone and welcome here again. For this video, I'll turn this Windows PC into a machine running macOS, better known as Hackintosh. And I will go through the process step by step. If you've been around my channel for some time, you know that I'm kind of into running different operating systems on unsupported hardware. Running macOS on the regular x86-based PC was on my list for a long time already, but finally I managed to find some time for this. The machine that I will use for this whole adventure is this Dell Optiplex 5070. I did a thorough review and disassembly, including benchmarks on Windows, which we can later use to compare the results, in the previous video already. I'll put a card here in case you would be interested to more detail. This machine is equipped with an Intel Core i5-9500, 16GB of memory, and a 256GB NVMe SSD. This should be more than sufficient to run the latest version of macOS, Sequoia. During the video, I'll be mainly following Dortonia's OpenCore install guide and explain you how and where I made choices and adjustments for it to match with the machine that I will use and want to run Apple macOS. If you want to turn your own, probably different machine into a Hackintosh, you would need to go through the same steps and make some adjustments. Some basic knowledge is definitely required, but in general the process looks more overwhelming than it actually is. We currently have Windows 11 installed on this machine, and the goal is to replace that with macOS. Dual booting shouldn't be too hard as well, but I'd like to keep things simple for a first time. Exactly that is also the reason why I chose for this machine. It's not too old, not too new, has an integrated GPU, just an Ethernet connection, and no additional complexity which typically comes with a laptop, for example. Having an Intel CPU should make things easier opposed to AMD too, most likely as that's the platform Apple was using as well. Most of the work will be to prepare a USB drive, ideally between 4 and 32GB in size. We'll then boot our PC using that drive to install macOS. Obviously, we can't just boot directly into a standard macOS installer. Instead, we will need to put OpenCore on that drive with a configuration tailored to the hardware we have. And exactly getting that configuration right is what makes the whole process longer and a bit more complicated. All preparation will be done from the currently installed Windows on this Optiplex 5070. In practice, I do recommend instead to use a separate PC or at least have another machine available, as that will allow us to make corrections during the process. If you would go through this process yourself, it's very likely that you will need to go through several iterations to make corrections to your config each time. That's also what I've been through, so this definitely didn't work out completely from the first try. Let's get going now. As I just mentioned, we'll need a custom configuration for OpenCore, and that starts in understanding which hardware we actually have in this machine. We don't need to go into too much detail, so I'll take a look at the different sections of Task Manager. The CPU is, as mentioned, an Intel Core i5-9500. The network adapter we have is an Intel i219. We have an integrated Intel UHD Graphics 630 as GPU, and the SSD is a BC511 NVMe drive from SK Hynix. For the audio chip, we can only see that this is a Realtek device, but we'll come back to that. Now that we got the basic information collected, we can start preparing the USB drive. Here we have the option for either an offline or online installer. The online installer is smaller, but will need a working network connection. The offline installer doesn't need that, but can only be created from within macOS, which requires a working Mac or a virtual machine. As I used to think that was the only option, I actually did an earlier video on how to create a macOS installer from a macOS VM in Windows before. Turns out that doing this from Windows is pretty simple in comparison, so I decided to go for that approach instead. We will need to run several tools and scripts which all require Python to be installed. So let's download the latest version from the website and run through the installer as a first thing. Now that's been taken care of, let's also prepare our USB drive to make sure there aren't any leftover partitions or weird flags and we can start clean. If you haven't done so, insert the USB drive into your machine and then open this part. In this part, let's list the drives we have. The USB drive is disk 1, so let's select that one. Then, using the clean command, we can make sure everything is removed. And although this drive was already using GPT, it doesn't hurt to make sure. Next, we need to create a primary partition. format that with FAT32 as file system, and assign a free drive letter D in my case. So here we have our clean USB drive on which we need to put the recovery image together with OpenCore and the correct config, of course. Let's start with that first one and begin with downloading a macOS recovery image. This will be done using a script that is part of the OpenCore package. For everything that I will be downloading or refer to, you will find links in the description. So after going to the GitHub of OpenCore PKG, within the releases, you can see that there are two versions available. For now, we will start with using the latest debug version, as that will provide us a lot more info in case something would go wrong. After downloading the package and extracting it, we can then go to the Utilities subfolder and open a command prompt with Mac Recovery as the working directory. The command and arguments which you need to use to download specific macOS versions can be found in the guide in the Downloading macOS section. As I would like to install macOS Sequoia, which is the latest at the moment of creating this video, we need to copy the following command. After pressing enter, two files are being downloaded as you can see. Hold on. And this created a new folder in Mac Recovery called com.apple.recovery.boot, which contains those two files which we need. All we need to do now is to copy that folder over to the USB drive. That's it. As you can see, the downloaded basesystem.dmg and basesystem.chunklist are on the USB drive, so our first part is already done. The second part won't be that fast, and it is to get OpenCore on the USB drive with the correct configuration. As we already downloaded the OpenCore package, we can go to those extracted files, and from the x64 folder, we can copy over the EFI folder to the root of the USB drive as well. These are the base OpenCore files. The tools and drivers folder that came in the package contain a lot of files which we don't need, so let's clean up a bit here. In the drivers folder, the only thing to keep is openruntime.efi for now. And in the tools directory, we only need to keep openshell.efi. Next, we will need to collect the necessary files to go in these and other OC subfolders. What you need here completely depends on the hardware you have, so let's follow the guide part by part and apply this. For the drivers folder, the first section is universal. We need both hfsplus.efi and openruntime.efi. That second file was part of the OpenCore package already, and we left it in the drivers folder. hfsplus, we can just download from the link provided and then copy it to the same directory. The next section is to find the right gext, or better known as kernel extensions. Let's start with the must-haves. We need Lilu, so let's download it, extract it, and copy it over to the gext directory. Same for virtual SMC. We can download the package, extract it, and then copy over virtual smc.gext first. Then we need to select which plugins we need for that. SMC Processor, SMC Super I/O, and SMC Dell Sensors seem to be the best match for our hardware, as we don't have a laptop, no AMD CPU, or AMD GPU. These go in the gext folder as well. After this, we also need to move the included tools to the same place in the EFI/OC folder. The next part is about graphics. Here we simply need to download whatever green and copy that over to the gext folder as well. For audio, things will still get a bit more complicated, but at this point, we again just need to download Apple ALC and copy that kext to the correct folder as well. Apple ALC requires you to provide a layout ID to the boot parameters, and for this machine, we'll also need to fix an IRQ conflict, but we'll come back to that later. Ethernet is the next piece of hardware to cover. In Task Manager, we could see that we have an Intel i219 in this machine, which means we can use the Intel Mousy driver. Same again here, just download, extract, and copy the kext file to the kext folder. For USB, as is the case with audio, there will be some more work to do, but for now we can just download USB Toolbox from the releases, extract it, and move the kernel extension to the same folder. Wi-Fi and Bluetooth can be skipped. Same goes for the AMD CPU specific kexts, and we don't need any extras or laptop input either. The next section to go through is about SSDTs. SSDT stands for Secondary System Descriptor Table, and simply said, these files map out the hardware and firmware to the operating system. Which files to choose is based on the CPU platform we have. Our CPU is a Core i5 9500 as you know, and this is part of the desktop Coffee Lake platform. So this means we need to get SSDT plug, SSDT X USB X, SSDT AWAC, and SSDT PMC. For each of these, which I open in a separate tab now, we can just download the prebuilt.aml file. Once we have all 4 of them, we can copy these into the ACPI folder under OC. At this point, we almost collected all the files we need. I did mention that audio and USB do require some more work, and it's time to tackle these now. First, audio. Here we could see that our audio driver in Windows just reports a generic Realtek device. In the BIOS setup, we get some more detail, and audio here is listed as a Realtek ALC 3234. Further investigation with codec dump shows that this is actually a Realtek ALC 225, and we will need to use layout ID 11 for Apple ALC. Providing the correct layout ID in NVRAM is to be done when we will be creating the config.plist, but unfortunately it's not enough as this results in an IRQ conflict. To overcome this as well, we will need to run a tool called SSDT time. We can download the code, extract it, and then run SSDT time by executing this bat file. In here, we need to start with option P to dump the ACPI tables. Next, we need to patch out IRQ conflicts with option 1. And once these conflicts are found, we can simply press enter and use the default option. The result of this is a new folder called results, which contains a compiled SSDT called SSDT-hpet.aml and the data we need to add to our config.plist later to be able to use it. For now, we will leave these where they are and we can move to the USB portion. Again, we'll need a small tool. This time it's called USB Toolbox. We already copied the matching text, but still need to generate a machine-specific config file as well. The goal of this is to map out the USB ports that are present on our PC. This can be done by running this tool and plugging a device into each USB port, going over them one by one until they are all detected properly. From the releases, we can download the Windows executable here, and then run it. In the tool, we need to use option D. And then we can move around our USB drive, each time waiting for the tool to detect it in a new port. After changing the device each time, you need to wait for a green line. Don't rush this and make sure it got detected properly every time. Alright, we managed to go through all 10 ports, 4 in the front, 6 on the back, and now we can press B. In the menu, we now have to choose option S. Here we can see that 10 ports were detected, exactly as we want to see. And by using option K, we can build a matching utbmap.txt. This file then ends up in your download folder, and we can move that to the USB drive under the kext folder as well. We're almost there. The last hurdle to go through is to create a config.plist, which basically tells OpenCore how to behave and use all of the files which we just collected. As a starting point, copy over the sample file from the docs folder in the OpenCore package to the OC folder on the USB drive and rename it to config.plist. Then we'll need to use one more tool called property. On the GitHub page, just download the code again, extract it, and then run property.bat. In the property UI, go to File, Open, and navigate to the file you just created on the USB drive, which we called config.plist. We can start already by deleting these first 4 entries here, just so things look clean. Then we need to do an OC clean snapshot from the file menu. This will detect all the files which you collected in our OC folder and generate the matching config for it for your config.plist. Make sure we are in EFI OC on the USB drive and press Select Folder. As you can see, this immediately populated the configuration with all the files which we prepared. Now we will need to make some adjustments. This is again based on the CPU platform which we have, which is still the Intel Desktop Coffee Lake. The guide goes over the full config.plist, and it's important to follow this one by one in detail. For the video, I'll just go over this quickly and point out any specifics that need a bit of a different approach than what is mentioned in the guide. ACPI we can leave as is, generated with the clean snapshot. Booter quirks require some changes as defined in the guide. Device properties add requires an additional dictionary which will configure whatever green to do frame buffer patching. So here we need to add the data exactly as described in the guide. Kernel quirks require some changes as showed in the guide. But one thing to pay attention to is that the screenshot here mentions to enable custom SMBIOS GUID for Dell systems, but this is not the case for ours. If you would enable this, you will get firmware errors when trying to use APFS, for example. Believe me, I tried. MISC debug needs some changes to log the boot messages. This will allow you to troubleshoot an unbootable system a lot easier. In NVRAM, we can change the boot args as in the guide. The only thing we need to change is the ALC ID, referring to that layout ID for Apple ALC. And for our audio hardware, as I mentioned, this needs to be set to 11 instead. And if you're paying attention here, you can see that I made a small mistake and used ACL ID instead of ALC ID. I only noticed this after macOS got installed, so we'll have to come back and correct this later. To get the correct values for platform info generic, we need another tool called GenSMBIOS. Download the code, extract it, and then run the GenSMBIOS.bat file. Choose option 1 first, followed by option 3. As outlined in the guide, we'll pretend this is an iMac 19,1, so enter that model here. After pressing enter, we get the required values which are generated, and then we can replace them in the config.plist. That's it. The rest of the sections do not require any changes, so we can go to File, Save, to save this into the config.plist on the USB drive. If you still remember, for audio, we also generated a .aml file and related configuration that needs to be merged with our config.plist. Before we do so, let's take a quick backup of that file so we don't lose our work if something will go wrong. Then we can go back to the SSDT time tool and run patch merge. This will merge the generated data with our created config.plist. So start the tool, use option 1, and drag the config.plist from the USB drive into the window. Then choose for option 2 to merge it with the config that was generated by SSDT time. The output is a new config.plist which you can find in the results folder, and we can use that to replace the file on the USB drive. We can see that the file size is slightly larger, which is a good sign. After replacing the config, we will also need to copy the ssdt-hpad.aml file to the ACPI folder. The hard part should be over now. Our USB drive is now fully prepared, and we can try to boot from it for the first time. Before we do so, as we will overwrite our Windows install, I'll take a quick copy of all the downloaded files in case we still need them. Then we can restart the system. Bring up the boot menu and enter the BIOS setup. Here we should change or verify some settings to match with the recommendations from the guide. In our case, we have UEFI enabled, Secure Boot is disabled, and the same for the serial port. SATA needs to run in AHCI mode, SGX is disabled, VTX is enabled, and VTD is disabled. That should be sufficient, so let's exit the BIOS setup, go to the boot menu, and this time select the USB drive. As you can see, it takes some time after those quick initial messages for something to show up. This is as expected. Eventually, we get to see the menu in OpenCore, and here we can only see Windows that is still on the NVMe drive. But by pressing the spacebar, we get to see a full list. The first entry here, called no-name external DMG, represents the macOS installer, and we can launch it by pressing enter. Initially, again, it looks like nothing is happening, but just be patient here, as the macOS installer is now being loaded from the USB drive. After some time, you should start to see verbose boot messages scroll by on the screen. These might not all look very positive, but to a certain degree, some errors or failures are to be expected. And if all goes well, we should end up in the macOS installer. This is exactly like it would look like on a real Apple Mac. Before we can install macOS now, we first need to go to Disk Utility to prepare our SSD. In Disk Utility, show all devices, select the NVMe SSD on the left, and then click Erase. We can give our SSD a name, leave the format as APFS, scheme as GUID, and then erase the drive. Now we can close Disk Utility and finally launch the macOS Sequoia installation. After agreeing to the license agreement, we can select our drive, which we just prepared, and click Continue to do the actual installation. The whole process will take some time. As we created an online installer, a lot of resources still need to be downloaded, so this heavily depends on your download speed. During this process, the machine will reboot several times, each time showing those verbose boot messages. Eventually, you should get to this Select Your Country or Region screen. This means that macOS is completely installed, and we need to run through this initial setup wizard. Again, this is exactly the same as if you would be doing a fresh installation on real Apple hardware. Already a good sign, I would say. For your information, until this point, the actual installation took around 20 to 25 minutes for me. Now, let's go through these steps quickly here. and eventually we should end up in macOS Sequoia. So this machine is now officially a real Hackintosh. Nice. The first thing we need to do here is to take a look at about this Mac, of course. We can see that all our hardware is recognized. Our CPU, GPU, and memory, and at first glance, everything looks pretty responsive as well. At this point, it looks like everything is looking fine, but we still need to take care of some smaller things. First of all, at this moment, we are still booting OpenCore from the USB drive. Without that drive, we'll not be able to boot into macOS. So we need to move that EFI folder with the OpenCore install from the USB drive to the internal drive instead. No name here represents that USB drive. And as you can see, each boot of the system created a log file here, which is very useful to debug a non-booting system. Let's make a copy of the EFI folder on the desktop for clarity. Then we can use a tool called mount EFI to mount the internal drive's EFI partition in macOS. Download the code and then run mount EFI.command. Unfortunately, the security settings in Sequoia are pretty strict, so we need to go to System Settings, Privacy and Security, scroll all the way to the bottom here, and then allow the script to be executed. As this is the very first script that we are running on this fresh install, we need to install Python here as a dependency as well. There we go. Mount EFI is started, and in here we can select option 1, which represents our internal NVMe SSD. This will mount the EFI partition on the same drive to macOS. For now, as you can see, it's still empty, and all we need to do is copy the EFI folder which we took from the USB drive also to this location. That's it. Let's test this now by a quick reboot without the USB drive in our system. That seems to work, and we no longer depend on the USB drive to boot up our Hackintosh. One step further, I would say. Since everything seems to be working as expected at this point, the next thing that I will change is to move away from the debug version of OpenCore and to disable those verbose boot messages. For the first part, we can download the release version of OpenCore and then replace the following files in our EFI folder on the internal drive. As I did before, I'll use mount EFI first to mount that partition, and then we can simply open it and replace those files as instructed. Now to disable the verbose messages, let me launch proper tree again. And open the config.plist from the internal drive EFI. In MISC debug, we can disable Apple debug, set the target to 3, and remove the -v from the boot arguments. And as I mentioned before already, but actually hadn't noticed till now, our sound is not working on macOS. When I go to System Settings, Sound, I don't see any internal audio devices. And that's because I made a typo here and used ACLID instead of ALCID. So let me save the config.plist with that additional change and reboot once again. We're seeing that OpenCore is now on the release version, and we're getting a pretty clean boot progress bar now, without those verbose messages scrolling by. Back in macOS, going to System Settings, Sound now shows us the internal speaker and line in. When playing a sample sound, looks like this got fixed as well, and even the volume up and down keys on the keyboard seem to work. Time for some benchmarks now, and next to how well this setup performs, I'm especially curious to see how well this Hackintosh will perform in comparison with the same hardware on Windows. First benchmark is Geekbench 5. As a result, we get 1181 for single core and 5290 for multi-core. Now, if we compare these numbers with the same test on Windows from earlier, we can see that what we got is almost identical. Very nice to see. Let's do the same now for Geekbench 6 as well. $1,517 for single core and 5,706 for multi-core. And again, these are very close to the results we got on Windows. As we can see as well, this machine even seems to be performing slightly better than a late 2019 MacBook Pro. Pretty impressive for a PC of only €8 if you ask me. Just as a formality, let's also test this performance on macOS. Not too bad. Slightly lower in comparison with Windows, but after all, this was a different test, and definitely those numbers aren't bad at all. That was all I have. I'm happy to finally have gone through this extensive process, but even more happy with the, at least to my ID, pretty impressive results. This cheap second-hand machine shows a very snappy and pleasant to work with experience in macOS. Everything seems to work just as good as in Windows, up to the point where I would seriously consider this setup for day-to-day work. Thank you for watching. I hope you have enjoyed the video as much as I did making it, and if that's the case, I'd appreciate a thumbs up. Let me know how this goes for you, or if you have any questions in the comments. And if you like these kind of videos, make sure to subscribe to my channel and enable notifications. Thanks again, and hope to see you back here soon.